Hello. So, chapter 14 in the carry text is on organometallic compounds. And the first topic that we're going to talk about a little bit is, what are these? And then the second topic is going to be on nomenclature. So, according to IUPAC, how do we name these? So, organometallic compounds are just like what they sound. This is an organic compound that is coordinated to a metal ion. Many times we're talking about lithium, magnesium, copper, or zinc. And so down here in this example that I placed, we would have what would be butane if it was fully an alkane. However, it now has a lithium attached to it. So, how do we name this according to IUPAC nomenclature? Well, it's a substituted derivative of the metal, so the metal is the parent name, and the alkyl group is named as a substituent. So, for example, let's just look at something like this. Let's say we have a 2-carbon-containing group coordinated to the lithium. The lithium is going to be the parent name, or the parent compound. I should say the parent atom. Whereas the 2-carbon-containing group is going to be the substituent. If we only had the 2-carbon-containing groups, it would be ethane. So therefore, if the 2-carbon-containing groups was hanging off of a larger alkane chain, it's called an ethyl group, correct? So therefore, this becomes ethyl lithium. It's a separate word. Okay? So we have the alkyl metal. Let's do another example. Okay? So in this example here, if we only look at the alkane, it would be called cyclohexane. However, so it would be cyclohexane. However, whenever cyclohexane is a substituent of something, you drop the ending you add the YL, so this would become cyclohexyl magnesium. Another thing to keep in mind is the fact that, remember, magnesium can be up to a 2+ charge, so therefore it can coordinate to two items. So we now have to remember to give the locant, not the locant, I'm sorry, but to give the prefix. So in this first example here, this would become dimethyl magnesium. And I'll give you a moment to work on the second one. Because this is the second compound, now we have things hanging off of the parent chain. So in this example here, we have 1, 2, 3, 4 carbons in the longest chain that's coordinated to the lithium. And then we've got these 2 other functional groups that's hanging off. So I like to do this from the backwards. The root is still going to be lithium. The parent alkyl chain has 4 carbons in it, so it becomes butyl. And then now we name the substituents hanging off of the butyl group. Those are methyl groups. And this would be a di. Now finally we give it the locants. 1,1-dimethylbutyl lithium. Because the lithium here is going to get the priority over the methyl groups. finally, if the organometallic compound has another non-carbon containing substituent, you treat the organometallic compound as a cation. You may think that this sounds confusing, and so how can we, what do I really mean by that? Just think, this isn't an organometallic compound, but if we have NaCl here, the Na is the metal, and it's a cation, so it just gets its name, which is sodium. And then the anion is chloride, because it's named after the anion. We only have to worry about this whenever the organometallic compound is able to make more than one interaction, more than one coordination. And so, for example, magnesium, copper, and zinc could do this. So let's just look at an example, another specific example here with magnesium. Okay, so first we want to name the metal, and you treat the metal as the organometallic compound as the cation. So in this example, we have 3 carbons and it's coordinated to the magnesium. So this becomes a propyl magnesium. And then you name the anion, which is iodide. Hopefully this helps you with the nomenclature of the organometallic compounds.